Okay, we're going to go ahead and get started. Can everyone hear me? All right, I'll assume everyone can hear me. Is my mic on? Okay. All right. So I'm Tim Siglin. I'm a contributing editor with Streaming Media Magazine, and I've been writing for the magazine for 21 years, and we were joking up here that I was talking about the early player wars of QuickTime, Windows Media, Reel, and one of the engineers said, I remember hearing about that. So I guess I'm officially the gray hair in the bunch. I'm also after 20 years in the industry, I helped start a not-for-profit called Help Me Stream. We focus on doing work with NGOs in emerging markets where the infrastructure isn't as robust as it may need to be, but we work to help do projects to get critical missioning out for the NGOs. I'm going to go ahead and start at the far end of the table and ask each of our panelists to introduce themselves, tell a little bit about their company, for those who may not be familiar, and we'll start with you, Subhrendu.
Yeah, so I'm Subhrendu. I work at Ellation, which is part of Warner Media today. What we do is we have an SVOD service. We primarily focus on anime content, so people who have not heard of, maybe Crunchyroll is our flagship product, and so we do a lot of video streaming, and I lead the video infrastructure team there. So,
very good.
Yeah, Nathan Egge from Mozilla. So I'm head of our Codec engineering team, and so this team is primarily concerned with doing research on media format. Specifically, we're trying to create best-in-class royalty-free standards for media on the internet. We help work on the Opus audio codec, which is royalty-free, helped standardize WebRTC, and then we've contributed to the AV1 royalty-free video format.
I just want to mention something with WebRTC. I was reminded this morning when I was doing an interview that WebRTC is essentially one of the oldest technologies in the industry, RTSP, wrapped with a number of other technologies around it. Why is that? Why did we go back to something that's 20 years old or older?
I think part of it is because it's UDP based. Okay. This work was being done at the IETF, so they like to build on other standards that they've made. That helps you get that ultra low latency you're looking for.
Sure, absolutely. All right, thanks.
I'm Vittorio Giovara. I'm a long-time open source contributor for multimedia FFmpeg for Videolan. I work at Vimeo. I'm a senior video encoding engineer in the transcoding team. I take care of everything that happens to the video from upload to storage, delivery, and playback.
Hey, my name is Tarek. I work for Twitch. I'm sure you know Twitch is owned by Amazon. Twitch main activity is live streaming. We do lots of esports and gaming live streaming, but we do different content as well, and we are launching new services all the time. I'm a principal video engineer, so I work mainly on codecs, evaluating technology, deploying new codecs and new platforms, and we are also part of Alliance for Open Media, and we contributed to the AV1 encoder. So.
And I think you did a panel, or you did a discussion recently, maybe at Demuxed, on S-frames and AV1.
That's right. S-frame is the switch frame which Twitch Amazon contributed to, which is more oriented to live streaming to improve latency. And we're hoping to see everyone who deploy or implement any AV1 decoding technology to make sure that feature properly implemented, because it's going to help our latency as we go and hopefully deploy AV1.
Okay, very good. So before we get started on some of the questions, let's define terms in this, because when we're talking about multiple codecs, there are a whole bunch of acronyms, and I'm going to throw acronyms out, and any one of you can pick this to define. I've got 4, so it'll be one a person. What is AVC or H.264?
It's advanced video coding, and H.264 is the follow-up to H.263 and so forth. So that's what it is.
And I guess maybe one of the questions, I assume most of the audience knows it, but why do we have 2 different names for the same codec?
One is a different standardization body. One is from the ITU side and the other from the ISO side.
Oh, right. So ITU and ISO having those 2 different names. And as you said, it was the replacement for 263, which was a replacement for 261 back in the day. What about HEVC?
Yeah, that's the high efficiency video coding, and that's the successor to 264.
Which is also called H265.
Sorry, yeah, it's also called H265. So it also has the dual license or dual standardization at 2 different bodies.
Okay, and what's the difference between AVC and HEVC for the audience?
It has a number of different modes. So it has more directional modes. It has larger block sizes.
Still uses IPB? Okay. And then on the macro block size, it's larger macro blocks, smaller macro blocks, variable?
I think it's larger macro blocks, right? So
It can vary.
64, yeah. So
Okay.
For
All right, fantastic. AV1, do you want to answer that one, Nathan, or do you want somebody else to answer?
Vittorio's next.
He's wearing the T-shirt.
Yeah,
I know he's wearing the T-shirt, that's why I asked.
I've talked about AV1 before. I'm happy to answer. So it's the successor to, or the logical, or the spiritual successor to VP9. So it's a combination of technologies that were contributed from Google, their VP10, Mozilla's Scala, and Cisco's Thor efforts. It's a combination of technologies that's been put together by this industry consortium called the Alliance for Open Media, and the idea is to cover like a very broad set of use cases. So they've got technologies in there that handle video on demand, that handle video conferencing, that handle video game streaming. They try to reach all the use cases they can.
And VP9 was, its precursors were VP8, VP7, VP6, which was On2 Corporation, which was acquired by Google.
That's right, yep.
Okay. And how much similarity does AV1 share to the On2 codecs? Because VP9 seemed to be a bit of a reworking of it, even though it was still nomenclatured as VP9.
Yeah, I mean, there's a number of things that are distinctly different. And part of that is due to things like S-frames that were added, stuff like the chroma from Luma that we contributed, the filters that were added by Cisco. We have a different arithmetic coder. There's a lot of things that are different. I think it has different transforms than VP9. So in many of the technologies, you can think of them as like we have like many more choices for them. So we have larger block sizes, we have more directional modes.
And are those choices essentially similar to the way that HEVC adds more choices above AVC, or are there major differentiators that would be in there as opposed to just codec quality?
I mean, just generally when you think about how you get better compression from a video codec, you're going to do that by allowing you to more closely match the content you have. So having tools that have more specificity is important. Now, the mechanisms you get them are very different, right? So for one of the tools like this Chroma from Luma tool that we contributed from Mozilla, I don't think that looks like anything in HEVC at all, and that ended up getting us very good gains on what we thought was novel content, this video game streaming content. It matched that content very well.
Can you explain a little bit more about the Chroma from Luma?
Yeah, I mean, I'm happy to. And if I start monopolizing the mic, be sure to cut me off. But the way that technique works is, your video frame, when you do this YCBCR color conversion, it decorrelates information kind of globally across the frame, but locally you still have a correlation. And so we take the reconstructed Luma pixels, and we use them with a scaler to predict the chroma pixels. And so we like signal two values, one for the different planes, one for each plane, and then we just multiply the reconstructed Luma, and we get a very accurate predictor for the chroma.
And does that have any benefit on say a 420 versus 422 versus 444?
The only way to think about that is that there's some decoded cost as you have to downsample your 444, right? You just use a normal box filter, it's not that expensive.
Right, sure. Okay. Two more acronyms, VVC.
I'll go for that.
Right.
Versatile video coding, still being standardized or still being created actually as we speak, and expecting the standard to be there by October 2020. It is very comparable to AV1 in terms, same logic actually, block-based video coding. It's more about investigating more computationally expensive features, different transforms, different block sizes, but the logic is the same. At the moment, it stands at about 30% better compression efficiency than HEVC. Complexity is about 8 to 9 times in the encoder side, less than 2 times the complexity of HEVC. If I go away from the technology side, it's probably another scenario from an HEVC that's going to happen. But
You're saying from a licensing standpoint, or?
it's exactly following the steps of HEVC. So the same companies are contributing the same approach. JVAT doesn't have any say in terms of enforcing any licensing mechanism or conditions. So we'll see what's going to happen in 2 or 3 years.
Okay, we'll actually come back to licensing in a bit, and EVC sort of plays into that, so we'll come back to that at some point. What's the compelling reason, and I'll throw this out to any of the panelists, what's the compelling reason to consider having a multiple codec approach? I mentioned Real, Windows Media, QuickTime, way back in the day before we sort of standardized around H.264 and AVC. It was multiple codecs, and you had to do true transcoding as opposed to transrating or transmuxing. What are the benefits to doing multiple codecs? And I'll start with you, Tarek, because I know that when I did the interview with you last year, you were a single codec focused, and then you've moved to be several codecs.
The reason moving from obviously AVC, which is now a little bit old, to a new codec, whatever it is going to be, obviously to save money and deliver new services, which are both the two strongest arguments. Save money in terms of delivering the same what we have today at lower cost, so that we can keep growing and scaling. But also we need new codecs which can deliver higher resolution, higher frame rate, higher bit depth, HDR, and all these services will definitely be ready for streaming, I would say, in a couple of years' time. And actually, that decision is pretty tough because it's not cheap to deploy a second encoder. It's actually quite expensive because none of the encoders today will cover the whole platforms that we stream at. So at this point of time, AVC is universal. None of the other encoders available or coming is expected really to cover the whole set of platforms any soon, which means we're going to go not replacing but adding a second encoding technology, which will save us money, but will be very challenging and expensive to deploy as well. Imagine Twitch has got hundreds of thousands of channels.
So I guess that's the question, is in this transitional period, if you're saving money on delivery by using something like HEVC or AV1, but it's costing you more in terms of resources from an engineering standpoint, is it a model that says it's more cost effective in a 4 or 5 year period of time, or it's more cost effective in an 18-month period of time?
That's a very good point. We are deploying VP9 this year. That means deploying VP9 this year in parallel with AVC is cost effective already.
Okay.
But we're looking at longer term as well. And if the numbers will not match, will not show gain, we wouldn't have deployed VP9. So
Okay,
there is definitely a benefit as the compression ratio is good enough. I think we're expecting a VP9 savings of at least 25% compared to AVC. That number is already good enough to get us started.
So the overall, to make sure I understand, the overall delivery savings you make far outweighs the NRE initial cost that you're going to have to put into it.
That is correct.
Okay. Vittorio, your take?
So my point of view is that having a multiple codec work is perfectly fine as long as a new codec is an enabler for something that you couldn't previously do with your codec choice. Case in example, Vimeo launched 2 years ago HEVC, an HEVC service only because it allowed it to stream HDR content and 10-bit content. This is, of course, an important selling point because streaming HDR allows for streaming better fidelity content and better quality videos. But of course, this does not apply to anybody. Switching a codec without having a clear benefit, just introducing VP9 without having a clear idea of the benefit is not as effective as allowing a new service category entirely, in my opinion.
So just a quick question. Both of you mentioned HDR and you mentioned 10-bit, so deeper, color bit depth.
Yeah.
Are you seeing equivalent bandwidths for that with HEVC, or are you seeing bandwidth savings plus the ability to do HDR and 10-bit?
So the Vimeo position is a bit unique because Vimeo cares a lot about quality. So even if HEVC has some bandwidth savings, we prefer to keep the same bandwidth as H264 and offer more quality so that there is more studio level streaming available. And the 10-bit is important for us because a lot of our content creators upload ProRes H264 10-bit.
That's content that's already intended.
Exactly. And so it's important for us to be able to preserve the information that the creators entrust us.
So this is a completely subjective question, but, and I understand because you work with a lot of professional content creators who do 10-bit, as you say, ProRes. They may see that it carries consistently through with the quality, but do the end users who are viewing the content subjectively notice that there's a better quality?
Oh, yes, they are absolutely familiar with the quality, and whenever we have like when we stress the compression too much, we immediately receive notice like saying, why is my content not showing as good as it used to? So our users keep us on our toes for quality, yes.
So people go back and look at previous content and say, that doesn't look nearly as good now that,
Yes.
I've seen 10-bit HDR. Okay,
Yes.
interesting. Nathan, your take?
On the multi-codec?
Yeah, implementing multiple codecs as opposed to a single.
Yeah, I mean, I think there is some added cost there. You know, the I guess best example of a place where we had to look at this was with the WebRTC standardization effort, where it took, I think, 3.5 years to come to. We were presenting codec options. When we talked about audio, it was very obvious. Like we presented Opus and I think G611 or whatever, G611, and so those two were like the two mandatory to implement audio codecs. When it came to video, it took 3.5 years, and we didn't actually end up with a single mandatory to implement video codec. We ended up with two, VP8 and 264, and that created a bunch of compatibility issues, right? I mean, you had broader reach because like maybe you could get to different access points that you couldn't get to before, but now you have these boxes in the middle to do with compatibility, and so there's some trade-offs that were made there, and I think that it's a successful standard in that people are using it, and so you have to kind of deal with some of the extra costs to reach that broader audience.
To a certain extent, it almost sounds like the discussions we had around HTML5 video and audio tags, where the assumption was the video tag was going to be to a single codec, and ultimately you had to make call-outs.
Yeah, that was another unfortunate set of discussions that didn't get to a place where we ensured compatibility.
So do you also see what Tarek and Vittorio were talking about with HDR? I mean, is that a reason to implement, or is bandwidth savings a more primary reason?
I agree with them that reaching or enabling new use cases that you didn't have before is very compelling, and I think that as Vittorio said, this notion of say HDR as a 25% improvement or a 25% increase in total information content is a more compelling offering than going to 4K. Mm-hmm. Like the user experience is going to be much higher, and so moving to a codec that allows you to do that is going to enable that use case, and so dealing with multiple codecs to do that is totally rational and compelling.
So nobody's yet mentioned high frame rate, because what I've heard is 1080p 60 HDR versus 4K. Do you all see that there are requests to have high frame rate content along with HDR, or is it just HDR is sort of the more dominant, compelling reason?
By high frame rate, you mean 60 frames per second?
60 frames per second, yeah.
Yes, like Vimeo has introduced 60 frames per second several years ago, so yes, it's important to have, but I take it for granted right now.
Oh, really?
So
okay, so that's table stakes at this point. HDR is more of a differentiator.
Yeah, most of Twitch streaming is 1080p 60.
Okay, and it makes sense for gaming because of the high frame rate for action.
Gamers are very sensitive to frame rate, and people watching esports being broadcasted also are sensitive.
Okay, interesting. So Subhrendu, back to the question that I asked about multiple codec implementation.
So right now, for example, we are explicitly Crunchyroll up has everything in AVC. H.264 is what we offer. We have VP9 in the works in the lab today. Possibly within next few months we'll deploy that. So I would say multiple codec we have to look at it. When we started looking at it, we started looking at it from what makes sense from the business and the cost perspective. So I think the most important part is VP9 made sense for us because it was least barrier to entry kind of, as well as it gave us real cost benefits. So that was something we could easily get to. I think longer term also VP9 probably prepares us to get into the AV1 world easily. On things like HDR, I think those are good things to have. However, HDR has other limitations in terms of how many devices out there has HDR capabilities. So
Playback
for
capability.
playback. So really when we need to look at it, we have to look at it from the holistic end-to-end perspective and what benefit it gives to the users in a sense. And a lot of what Crunchyroll today offers is also, we have very strong fan base. So at times when we changed our bitrate ladder a little bit, fans actually took screenshots of frames and started comparing frames, and we had like long Reddit posts for those.
Now you
so-
know who to hire for your GoldenEye comparison.
Yeah, so we have to be very conscious about changing the quality levels and about that. So we have to take all those into consideration.
And are those discussions by fans because you're lowering the overall bit rate and they feel like they're getting lower quality because it's a lower bandwidth?
So I think we didn't actually lower the bitrate, but they saw a change in the bitrate, and then they took out specific frames and compared and said there was a change and this is bad, and when there are other parts which may be good. So I think we have to balance that out.
And out of curiosity, just to sort of follow on to that, so you got fans out there subjectively saying, hey, this looks good, this looks bad. If you run those back through, SSIM, PSNR, VMAF, objectively, do the algorithms show that they're essentially the same quality, or
They actually showed better quality. So
Interesting.
Yeah,
And
so-
this is the question about objective models versus subjective, which is not the topic of conversation today. But you're saying essentially it was giving you better readings.
Yes.
And yet fans were pulling out specific frames and saying
Yes.
it looked worse. How do you address that from a public relations standpoint?
Yeah, so I mean, it was more of a public relations issue rather than a technical issue.
Sure.
So I think, going forward, we have taken care of making sure we publicize much better in terms of what the changes we are making, and also explain and share data related to that. So for example, now we have set up a subjective video quality lab within the company, in which we do extensive testing in that.
And opinion scores and that type of thing?
Yes,
Okay.
so, and we collect this data, we validate across our set of streams that we identified. Also, interesting thing is, so lot of our content is anime, which is very unique in many ways,
Sure.
like cartoon, and it has sharp edges and anything at the sharp edges.
Limited color palettes. That type
Yes,
of thing.
so it needs a different kinds of input as well as tweaking of the codecs as well. So
Okay. Tarek, you have somewhat unique content too, obviously if it's streaming of gameplay and like that. Have you faced similar issues as you're implementing VP9 that it will say, objectively the algorithm says, oh, this is going to be just as good or better, and people give you feedback that it isn't or is?
Actually, that's a bit funny. The same thing happened to us, although we didn't launch yet. So during development phase, we have a channel called Twitch/VP9 Dev. Probably the name was not secretive enough, and someone happened to find the channel and start watching our VP9. And although that channel was not meant for video quality, it was more for functionality.
Right.
We've seen comments of, oh, Twitch are deploying VP9, but the quality is not good yet, or people, and that was
So
kind
it
of
was an
surprising.
open beta, so to speak.
Exactly, and that's very interesting. However, internally, we definitely, because when you evaluate the VP9 encoder, you evaluate it in a very, I would say, broad way. You have clips, you put it in AVC, you put it in VP9, you look at the streams, you do all the professional PSNR, VMAF, SSIM, you do your MOS. then when you come to deploy, things are different. It's real time, you have the content going at the same time to your AVC encoder, your VP9 encoder, and you watch side by side. What we did is we did an extensive set of experiments to define what is our bitrate ladder for VP9. And our goal is to make sure subjectively the difference is not noticeable. And we run lots of expensive and extensive set of evaluation. We ended up internally at least saying, you know what, no one can see the difference. We're going to wait for the launch and see how it goes, but we're going to be monitoring
I think
this.
what Subhrendu said, you'll get feedback. Because your people, as you say, are very sensitive to both frame rate and quality.
100%. Actually, at some instances, we're going to have a better quality. The challenging one is the highest rendition, the 1080p60. All the others, we are confident our quality is better. 1080p60 is always a little challenge.
So you mentioned that you looked and you're sort of defining a bitrate ladder for VP9. How, from a percentage standpoint, how different is that from the ladder for H.264 or AVC?
It is quite different in the sense that obviously we are deploying VP9 to reduce on bitrate, but we would like the ultimate experience to be the same, or the final visual quality to be the same. And people will be able to see our H.264 and VP9 on different browsers, and they might. Anyone can have that opportunity because VP9 will be running on Chrome and Firefox. AVC will be running on the other platforms, and this is, again, where platforms don't support VP9. So someone will open both browsers and look at them, not only from quality point of view, from latency point of view.
Exactly.
So there is lots of challenge we're trying to solve, but at this stage, we're running an extensive set of experiments, and we seem to be on the right path.
Okay, very good. Vittorio, from the standpoint of AVC and HEVC, with the implementations that you all have done, have you received feedback? I mean, we talked about the fact that the content creator sees better quality and the end user potentially sees better quality. Have there been models where, or times where somebody says, hey, the quality doesn't look as good as it did before?
Not that I can recall. One thing that really made a difference between when we, for example, when we launched the 60 frame per second and the HEVC services, is that we did much better outreach for advertising this event. And I believe that in our industry, being able to explain to your audience the technical advantages that are happening within your company is essential and helps them understand, depending on the audience, how technical it is. It helps them understand how well your process is, and they can actually help you integrate solution and identify problems.
Okay, interesting. So, Subhrendu, you mentioned implementation of VP9 to sort of get you ready for AV1. Tarek, is that a similar model from Twitch's standpoint, especially if you contributed S-frames and that type of thing to AV1?
Absolutely. I mean, for years we've been in AVC-centric, so even if you look at the way the AVC transcoding path from ingest to delivery is kind of AVC aware. There are lots of blogs that know you're doing a single encode. What we're doing by deploying VP9 is not only having a parallel path, but making our platform, and this is something we're going to talk about tomorrow at 10 a.m. in this room, at 10:30 actually, with deeper technical details. Now we are very confident that we have a channel in the future. If you want to add HEVC, VVC, or AV1, we just need to add that channel. That channel will tick a box saying, give it AV1 as well. And the whole infrastructure will handle that for us. So this huge exercise is not only for VP9 deployment, but for getting multi-codec ready.
Right, and I think that was one of the things that struck me in the interview that you and I did at Stream Media West was it was a rethinking of the entire workflow because of the fact that it could be n number of codecs as opposed to just a second codec.
Absolutely, although that's going to be expensive, and we hope that doesn't happen, but at least we are ready from a technology point of view.
And so Nathan, the question to you from the AV1 standpoint is one of the recommendations to people who are thinking about AV1 to implement VP9 first, understand that, or is there a benefit to sort of ignoring that and looking just at AV1?
I think that for people who have implemented VP9, because the interfaces for feeding frames and getting packets out are almost identical because we started from a descendant of the libVPX code base. If you've already implemented VP9, moving over to using AV1 is not a very difficult path to follow. So in that sense, I don't think we're suggesting to people, oh, you should,
first implement.
You should go first to VP9. I think if you haven't done either one, like going to AV1 is just fine. And if you have done VP9, moving to AV1 is not as painful as it would sound.
And Tarek, you all made the decision to go to VP9 before AV1 was sort of at the point that was ready for production. So that's why you've opted to go that path still.
That is, we decided on VP9 end of 2017.
Okay, very good.
If I can provide a counterpoint, Vimeo actually skipped the VP9 because there were very little savings compared to HEVC and roughly H264 as well.
Mm-hmm.
So we are switching directly to AV1 because there is no platform that does not support VP9 and supports AV1. So for a while we will have AV1 and HEVC at the same time, and hopefully one day we will only have AV1.
In fact, we'll come back to a discussion around hardware here in just a minute. But first, I want to open the floor for questions from the audience. And I think we may have a microphone. Hang on just a minute. Let me make sure that we have a microphone. I've got you as well. I guess not. So go ahead and ask your question. I'll repeat the question.
Okay, this is for Tarek mainly. What drove the decision for VP9 over HEVC? Was it because of the royalty-free nature of VP9, or was it more because your user base tended to be on browsers where there was broader support or something else?
Let me repeat the question first, just so we get the capture. So the question is, why did Twitch choose to go, rather than going AVC to HEVC, go AVC and VP9 at the same time? Was it a benefit because of the customer base on browsers or some other reason?
It's the latter one. Basically, what we did is we looked at minutes consumption platforms. So more than 50% of Twitch minutes go on Chrome. That's already first answer for you. Firefox as well is about 10%, lots of Android devices. So when we compared how many minutes, if we deploy VP9 and HEVC, 60 or 70% of our minutes will be consumed on VP9 versus around 10% on HEVC. And that's before even we talk about licensing issues.
And that would be native consumption in the browser as opposed to putting a plugin in using
Absolutely,
AVC.
absolutely.
Okay, very good. Go ahead.
I have two questions.
Okay.
Any plans to use scalable video coding in HEVC 1.264? And another one, are you using 10-bit coding?
All right, let's.
For HEVC?
Okay, so let me ask the first question first so that it's captured on. First question is, looking at alternatives like SVC and scalable video coding was something that was proposed 7-8 years ago, I believe, and has been around for quite some time. So the reasoning for going to something other than scalable video coding, I guess, has that been contemplated?
Even AVC have got scalable video coding, and it was not deployed really in the industry, and the industry opted more for kind of the ABR streaming. For HEVC, I don't have an answer because we don't have currently plans for HEVC. And 10-bit is not an option for AVC because all the platform and decoding hardware is 8-bit.
Okay. All right, any other?
Yeah, I can only add that SVC is very hard to implement, and it's device support is not there at all. So even if we had a service like that, it would be too difficult for the audience to receive it. And regarding 10-bit, yes, HEVC should be only used in 10-bit, in my opinion. Like any new codec should be only have 10-bit or higher.
I know, but I'm asking about HEVC 10.
Yes. Well, Chrome does support H264 10-bit, but that's the only platform that does. So.
Yeah, and there are capabilities for HDR within AVC, but it's fairly limited versus the others. I guess VVC is sort of moving in the direction of some of the supposed benefits of SVC, so we may get another shot at some of those scenarios. It seems interesting throughout the industry. Been in for 21 years. We had multi-bit rate back in the day. And then with SVC, that was sort of the model, was we could do multi-bit rate, and have a ladder. But as one of you said, adaptive bit rate sort of took over from that particular scenario. Any other questions real quick before we go on to the rest of our list? Let's talk about speed in encoding. I know Jan's here in the audience, and he likes to keep track of how how quickly encoders encode and the quality, et cetera. Some of the early complaints with AV1 were it took forever to encode something. Obviously that has, we've been optimizing and optimizing and optimizing. Where do we stand right now in terms of encode speeds for, say, live with HEVC and AV1, and then for on-demand 10-bit HDR at a high frame rate? Do we have sort of ballparks that we can talk about?
I don't know. Like I mean, we have not done explicit for AV1 or HEVC, both of them. We have not touched yet, so I don't have numbers right now on those.
Yeah, I mean, I think the most sensible answer can be, you'd want to look to something like the SVT AV1 announcement that came out from Intel and Netflix at NAB, where that's an encoder that's designed to be used in those use cases. It's still kind of early since that was just last month.
Sure.
I don't have any figures offhand, memorized, but I would do testing on that encoder if I was going to try to evaluate that use case.
To be able to do a comparison.
Yeah, I think libaom was certainly not designed for that use case, and
Right.
that this other encoder has that one in mind.
Okay, interesting.
I might add on that something, actually. Since we do live is our
Sure.
bread and butter, really.
99%, if I remember correctly.
Correct.
Yeah.
So, and I have an impression when people talk about speed, they always have in mind CPU, software implementation of an encoder. When we came to deploy VP9, VP9 is nowhere near successful, hopefully, than AV1. I'm hoping to see brighter days for AV1, and all the signs are suggesting that's going to happen. We approached everyone who was doing any work related to VP9 to see if there is a software implementation for VP9 which can run real time, with some gains, obviously. You don't expect VP9 at worse quality than AVC. And there is none. libVPX itself, which is the implementation of VP9, when you try to run it at real time, when I say real time, I mean 1080p 60, it does not deliver that. It's not optimized. It's a model, mainly. It has been slightly optimized, but it doesn't generate anywhere near real time with gain. And that's why we ended up picking an FPGA-based solution for our VP9 to get the gains. And although now we're excited about all the efforts we're seeing in AV1, SVT AV1, all the development on software, we do hope as well people with hardware capability will investigate and try to deliver, because we have a feeling hardware is what's going to deliver the gains of AV1 in real-time implementation.
Sure, at least for the next 4 to 5 years.
Exactly, yeah.
I would say that both VP9 and HVC have poor tooling support, maybe because of the codec war and the industry didn't know what to choose. But compared to H264 and now to AV1, there are way fewer players that are able to provide proper encoding support, and so there is less competition in the market, and with less competition there is less reason to innovate and improve the speed settings.
And is that why, sort of to Tarek's point, we see fewer hardware implementations?
Yes,
Okay.
I completely agree.
Interesting.
So I want to add one point. So I think speed matters, especially for live streaming or anything close to live. For any VOD services, in a lot of sense, speed doesn't matter. Like I can allocate CPU for 2 days and get some output, and if it gives me 50% bitrate savings, that will overall save me a lot more money than the 2 days worth of encoding time.
But at some point, there's also a threshold if it's going to take you 10 days to do it.
Yeah, so
right.
there is obviously a threshold, but I think AV1 has not reached that stage where the threshold is on that level that we can deploy that. Also, there is like support on the players and on the devices out there. That's another issue out there. But purely on the encoding side, I don't think AV1 is there. But for VOD, the challenges are less.
Okay.
You should also, sorry for interrupting,
No, go
you should
ahead.
also look at the content. So for example, Netflix, they can allow themselves to transcoding the 1 hour over 7 days of B3 machines running, because that content is going to be watched by millions, as mentioned by Jan this morning. We have lots of UGC content, user-generated content. Some of our content is going to be watched by 3 people.
Right.
We cannot spend lots of money on that.
It's the
content.
early YouTube problem, isn't it? Yeah.
Exactly.
A lot of encoding time for something that's not going to be viewed by that many people.
And that's why, for example, YouTube, they do kind of gradual transcoding based on viewership.
Sure.
From our side, it's pretty much the same. We need to make sure, even for offline encoding, it must be fast enough, otherwise it's going to be too expensive for whatever we're going to offer.
Okay. Subhrendu, you brought up an interesting point about the hardware on the decode side. And one of the questions that was suggested by a panelist was essentially this, that device-based hardware for video decoding currently governs the codec choice because the hardware only supports specific codecs. How do we get to a point where we either open up the hardware from a decoding standpoint or optimize the decoders so that they work with the sort of existing hardware that's out there? And obviously there's a licensing component. Let's not talk about the licensing component, let's talk about the technical component.
So I mean, that's kind of my hope for the next 5-6 years, that like as this multi-codec work goes forward, ultimately from the distribution side, we'll start producing multiple codecs out there. Like maybe we do AVC, we do HEVC and AV1, just as an example, just because of, let's say an Apple device won't have AV1, and another device will only have AV1 but won't have HEVC.
Just like the problem we have with browsers.
Yes, so, and that will force distribution to have to implement this multiple codecs out there. If the hardware is more open in terms of using the fundamental pieces to implement different decoders at a more like an FPGA kind of solution, that will open up the ecosystem much better. Whether that will happen, I don't, it's very unclear. Probably it will not happen, but a similar open source initiative like AV1 on the encoder side kind of needs to happen on the hardware decoding side as well.
And before the rest of you answer, I just wanted to comment on that. I think one of the things that was interesting to me a few years ago was there was a media server company who wanted to support streaming on Blackberries. And Blackberries, of course, didn't have a lot of decoders. So they figured out a way to do an open-ended MP4 file that was sent to it. So the device thought it was just playing an MP4 file locally, and in fact, they were just feeding and feeding and feeding it. That took care of the problem with the constraint within both the hardware and the software. So Nathan, from a hardware standpoint, how do we get to a point where we can plug and play decodes into the mix?
Yeah, so I mean, I'm certainly not a hardware engineer, but I did want to just mention that the Alliance did sponsor the development of a very high-performance AV1 decoder called David. David is an AV1 decoder, so it's a recursive acronym.
Like new.
Like many in the open source world, right? There have been a number of blog posts about it. They're on, I think, version 0.3 just came out recently, and it's incredibly fast. It's about 2 to 5 times faster than the libam decoder, which has also been optimized at the same time. It's highly scalable, so the more cores you have, the more threads you have, the faster you can decode, and obviously, if you've got these frame reordering structures, you can decode into the future before you show frames, and it exploits all that parallelism that's inherent in the file format, tile threading, frame threading, things like that. And if you look at the stats, for devices today that are mobile, where you're on battery, not plugged into the wall, it's probably not a viable solution, even if technically you could use it there. And certainly we need to wait for real SoC solutions and hardware. But for anything that's plugged into the wall, your smart TV, my laptop, your desktop, those devices have sufficient compute capability to probably, and we have numbers to back this up per chip type, to handle decoding, say, 4K at 30 frames a second today. And that piece of technology is BSD licensed, it's open source, you can fork it, add your own secret sauce if you've got partial hardware implementations you want to deploy. And you can use it today to actually reach audiences that maybe you thought you would have to wait for hardware to be available for.
And is David optimized for Intel desktop and AMD desktop, or is it also for Qualcomm Snapdragons, ARMs, et cetera?
The answer is yes. So the call for proposal specified that you had to optimize like full SIMD optimization for 32-bit Intel, 64-bit Intel, ARM v7 and ARM v8. And right now they've actually been able to hit most of the targets. There are more things that can be done for 10-bit and 12-bit video. There are more things that can be done on ARM that haven't been done yet, and those are still in progress, but I encourage you to evaluate it today.
Okay, all right. So essentially it's ARM 8-bit, but the potential of 10 and 12.
No, there's full 10-bit support.
Okay.
It's just we can do more to make it faster.
Okay. got it.
And it may be done already as of the time of this talk.
Okay. Vittorio, any take sort of on how to open the hardware up on the decoding side?
I can say that a lot of the decision is in hardware, but there's also a lot possible in software, because more and more power is being embedded in the CPUs of television, TV sets, set-top boxes, and adding new features, new decoders to those platforms is theoretically easy. It depends if it makes product and market sense. It's going to be interesting how the evolution and integration of AV1 and or VVC will happen, and that will probably decide whether there will be another war between those two codecs, or if there will be a clear winner.
Okay. Tarek?
I don't think there will be any opening in the hardware, to be honest. I think on mobile devices it must be an SoC for the reason of power consumption. You cannot put a GPU running. It's still going to consume high power.
Sure.
And basically, the decision of which codec to win at some point, or having a platform that you can run multiple codecs, is going to be tricky to have. Probably legacy encoders will still be there, legacy decoders, AVC will stay there. It's going to be a tiny fraction of the whole SoC itself. Maybe HEVC might stay in VP9, but when it comes to VVC, AV1, I think only one will make it really. From connected devices, I fully agree. Software will be the initial ones people will use for decoding, but still even CPUs will have graphics, hardware and graphics accelerated decoders. So I don't see the industry moving from the same SoC hard-coded model. But they will try to deploy as many decoders as they can. The legacy will stay there. I think when it comes to future, the internet industry seems to be moving towards the internet encoder, decoder support. So that's why AV1 has got high chances here.
Okay. And then sort of along those lines, what models will we look at? I know we've tried this a couple times in the industry of actually having a player that would be able to play back multiple codecs and using multiple codecs within a given video asset. How likely are we to actually get to that model as we have all these different codecs sort of jockeying for position? Because some codecs seem to be better for, you know, as we talked about HDR, some seem to be better for fast motion, et cetera.
In terms of switching, I'll start with this because I was interviewing a guy from an SoC manufacturer. So basically, nowadays the SoCs can decode different formats at the same time, which means you can, in theory, have the first part of your stream H.264 and the second part is HEVC, and that's seamless. Whether this is practical, especially in live streaming, I don't think so. At least from my point of view, I don't see a use case where we're going to benefit from such a feature, although it is there. I know, for example, you can have a ladder where only the 4K is HEVC, all the other renditions are AVC because you have a legacy set of encoded. You don't want to do dual storage. For our live streaming, I'm not so sure.
And maybe it's models like where you throw up a slate to say, you know, this show will start in 20 minutes. You may pick a codec for that that's limited in terms of motion, et cetera. But, so it may not be, we may not know the models to use for it yet, but you're saying at this point it is technically feasible with the SoCs.
Yeah, 100%. In fact, actually, lots of SoCs have got, at the same time, a dedicated AVC and dedicated HEVC decoders, and they can run multiple instances as well, or they can do time division multiplexing, and they do run a lot faster than real time, which means they can always catch up.
Yeah, so TDM makes perfect sense. Where in the decisioning, let's say you can do this, is it you're changing at the segment points with chunked content? So 30 chunks of AVC, and then the very next chunk of the manifest files HEVC? Or if you're doing live with, legacy RTSP, RTMP, could you even switch on a per frame basis?
Per frame would be tricky. I don't think that's possible. You need to do it at a keyframe or at segment boundary. You close an instance and you start another instance. That would be a very sophisticated thing to do, actually.
Okay. Anybody else want to add to that?
I think technically it's feasible even today, like switching between AVC to HEVC at segment boundaries or at GOP boundaries is possible. Whether it adds real value, that's questionable. At least between, say, AVC versus VP9 or AVC versus HEVC, there is a gap in quality level that comes into play. So there'll be question marks whether if I have a VP9 decoder available, then why try to do AVC at all? I think in the future, when the question comes between AV1 and VVC, if there are clear evidence that AV1 is particularly good for a very specific kind of content and VVC is good for another specific kind of content, there may be a use case, but I don't think we have enough evidence of that kind yet.
One of the models that I see that potentially makes sense is when you're handing off between, say, a Wi-Fi network and a cellular network. There may be a benefit there at some point to actually switching codecs briefly as you regain. But again, if it's technically possible, I think we may find solutions that will deal with that.
There is also a slight problem in the specification. I believe the MSE does not allow to switch codecs at all.
That is true.
So there is you need to be very careful when in your codecs selection. For example, going back to Vimeo and HDR, whenever we have on Safari, we switch to HVC. But anything else is H264. So, but it would be nice to be able to have only one rendition and a couple of extra files. But
right,
it's not possible.
and I think you're right. In sort of the classic browser model, it may be hard. But if it's a player that's actually designed to also handle multiple codec decodes, then the model could work. Nathan, you started to say something?
I mean, the only use case I could potentially see, and maybe it's hindered by some of the things we talked about in terms of browser support, is if you've got, say, a live stream where you're at 1 bit rate and you want to do ad insertion for whatever reason, you could hand off to some offline encode that would match bit rates, right? So you might switch to something that has been crunched a bunch to get something reasonable. There's probably very reasonable business incentives to use legacy ad generation, for a long tail, and you could see maybe doing something like that.
Fair point. All right, one last question, and we'll open up again for audience. I know this is a hot button question. How big a role does licensing have in codec choice versus technical benefits or limitations?
I would say from Crunchyroll's perspective, it is the biggest one in terms of deciding which one to choose or which one to go forward, I think. And also on the player side or on the device side, the support for that. So I think that's the first thing we consider before we decide of which one to experiment, which one to evaluate, and then roll out.
So even before you look at the technical benefits, is the question of what the licensing cost would be. Okay. Wow. Anybody else?
Twitch is part of Amazon. Amazon will only pay one licensing fee, so we don't really care. We care more about the compression efficiency and the playback support. So those two are not really available. That's why we didn't use HEVC.
Okay, interesting.
Maybe as a midway, like Vimeo does not care about the license, but if it was less expensive, it would be nice.
Oh, sure.
So,
yeah, and obviously I'm from Mozilla, so we ship
you're wearing
the
AV1
Firefox.
shirts,
We ship the Firefox web browser, and we cannot. It's impossible for us to include an HEVC decoder in that. Like, we ship software as binaries, but also source code. We don't count how many people use it.
Right.
Like, the licensing model doesn't work for us.
And that was, again, going back to HTML5, that was sort of one of the arguments around Mozilla with AVC. There was some compromise that sort of came into play there. Do you sense that that compromise may also come into play with HEVC down the line?
I don't expect that to happen again.
Okay. All right. They kicked the can once down the road, and they're not going to do it again.
You got one shot at it.
All right. Got it. Good deal. All right. We're going to open up for audience questions.
Another one for Tarek. So live streaming with hardware acceleration. I understand if if it's a user-generated content, I understand how you can do the transcoding with FPGAs, but are you expecting the end users to have an FPGA on their system for the contribution, or are you expecting them to use a higher bit rate to provide a higher quality mezzanine so that you can't transcode to a higher quality than you get, right? So how are you going to address that?
So the question is, you talked about using FPGAs for transcoding, at the core, but out at the edge as content is contributed, how do you expect to handle that kind of thing when you want the highest possible quality coming in from the end user?
That's a tough one. First of all, we're not going to change what we ingest today in terms of standards. So people still going to be ingesting RTMP AVC to Twitch. However, VP9 will allow us to tell to our not tail customers, but I would say premium, high viewership customers, hey, you can stream to Twitch at a high bit rate, which means we improve our ingested signal. That way we can transcode VP9, which will still gonna give us a good quality. You're absolutely right in the sense that if someone is streaming to Twitch at 6 megabits per second, we cannot make that signal better. What we try to do is at least when we transcode into VP9, keep it as good as we can. So if the ingest bitrate is so low, we're not gonna give VP9. If the ingest is good enough, we have a bar on which we say, beyond this point, we're gonna transcode into VP9, and that's when we trigger the VP9 ladder.
And where is that threshold? Or are you allowed to say?
That's at Twitch.
Okay.
That's not public yet.
All right, fair point. Do you see a model, sort of a follow-on to that, do you see a model of a hardware box for your premium customers that would optimize the push of content up to you?
Oh, that absolutely exists today. Lots of our customers use Elemental, which is a broadcast quality encoders. Some people go as high as 8.5 megabits per second on a very expensive hardware accelerated encoders. So we do, especially big broadcasters, or if we are covering a special event, we do receive very high bitrate input.
But what's interesting is Elemental sort of made their name in HEVC contribution, but you're saying you're only using RTMP AVC.
Yeah, we still only ingest AVC, and I don't see that changing at least for the next 12 months.
Okay.
Not less.
All right, great.
Let's give somebody else a chance.
Go ahead.
Yeah, so you guys have a lot of experience with new coders. How much improvement do you see year after year on encoding efficiency once a new codec is introduced? Because it's not a static situation, I'm assuming.
Yeah, let me recap that question. So, and I'm going to spin it slightly. Everybody who comes out with a new codec says it's 50% better than the last codec, but in reality, the optimization of that typically takes 3, 4, 5 years. Year over year, what kind of consistent gains should we expect with the newer codecs?
Yeah, so I mean, I'll start by saying that we did not make a claim of 50%. We made a claim of about 30%.
Okay.
And we hit that when we released. Internally, we're writing our own encoder, and we've kind of guessed that we can probably get another 10 to 15% using techniques that were not applied, mainly around rate control and perceptual tuning.
Yeah, perceptual, yeah.
Those are obviously not part of how you develop a format, right?
Right.
Because those things are too noisy for you to make reasonable decisions about how you design the syntax. So we're going to go and try to add those types of encoder optimizations, and we kind of think that that's roughly what we'll be able to get.
And there were some early attempts with the perceptual, if I remember correctly, maybe a year and a half ago with AV1, and those were pulled because they seemed to take too much time. And
yeah, I mean, there were some rate control models we tried to add. There were things that were definitely on the perceptual side that didn't have a meaningful impact to the format. Like we did enough of them to prove, okay, these are the levers we need to be able to implement them, and they didn't make it just because they weren't fully formed.
Okay. Anybody else?
In LibALM, right? Like we can go do them somewhere else.
Right, exactly. Anybody else feedback in terms of the optimization you expect year over year?
So, I mean, if I go back down the years when AVC first came out, or initial few years after that, AVC encoding by itself was getting better and better. Like every year, probably will some company or some, if you take different AVC encoders itself, they will have different performances, and you can figure out which one suits your requirements. When you come to the multi-codecs, I think on an average, as he mentioned, I think 30% is very reasonable to expect. 50% is probably a little too much. I haven't seen really 50% benefits, but 20 to 30% is probably what you can reasonably expect across your catalog, or also depends on your catalog. And then if you have only one specific kind of catalog, maybe you can optimize very heavily on that specific kind of catalog.
Yeah, let me just make sure I qualify that. So when I said 30%, we were very specifically saying 30% better than VP9 and HEVC.
Right.
Yeah.
That sort of generation. If you look back at AVC 264, some of the studies have shown, close to, upwards of 45, 47%
Right.
better. So it is actually, it's close to that 50% number, but that wasn't really the place we set our benchmark.
And in AVC's case, or H264, because we used it in video conferencing long before it came to streaming, the claims that were being made for VOD content were based around MPEG-2. It took us almost 6.5 years to get to where those claims were reality.
Yeah, there's definitely a long tail. I mean, I love to tell this anecdote. We produced a library for JPEG, MozJPEG, in 2014 that had some perceptual tuning in it and got like reasonably good gains out of this format that was standardized in 1991, right? Like,
Right,
so
right.
encouraging the industry to do investment in your format is going to like yield you these gains year over year. And so we're really enthusiastic about the number of people who have encoder products that they're working on. We think we're going to see some of these gains actually realized.
Nice. Anybody else?
MozJPEG user are very happy with it. No, I wanted to add that it's very interesting that new codecs take less and less time to be optimized. For
That is true,
example,
yeah.
H264 was standardized in 2003, and we had the first real encoders in 2008-9.
Right.
And the time frame for HEVC was much, much shorter, and for AV1 is incredibly short.
Right.
So it will be interesting to see how the situation
So
evolves.
it's Moore's law in reverse almost.
Yeah.
All right, well, I'd like everybody to join me in giving our panelists a round of applause. And I'm told from a housekeeping standpoint to tell you, don't forget that happy hour is from 5 to 6 in the exhibit hall, which is right now.
Thank you very much. Thank you very much.